Hello, guys. Good afternoon. Yes, hope everyone had the lunch. Yes, yes, Amit. I had my lunch. So we have not received mails regarding the login credentials. Okay, don't worry, you'll get it. Don't have the lunch, right? Nobody's sacrificing the lunch. Yes, Kushi, regarding the project, for time being, don't worry. Okay, after this 1 week, you will be getting all the credentials. Okay, meaning you will be first make sure whatever the email that you have registered, okay, initial, and whatever the email that you're using to join the session as well for the class, it has to be the same. And also self-paced course, I have asked you to go on with that, right, from IBM Cloud. So that also has to have the same email address. Make sure you have to have the common email address for everything. Okay, सर मुझे आपके एंड से हट दिया. I'm not sure. Vansh, did you do any mischievous things in the Telegram group? Yes, Janil Kumar. I'll just have a word with the operations team. Okay, these credentials and your projects, everything will be taken care by them. So I'll just have a word with them. Don't worry. By tomorrow, I'll give you some clarity on these credentials and everything. Okay. You're not able to add. That is what should you should have a common email address. Okay. So you do one thing, just put your email address in a Telegram group. Okay. Oh, I didn't even upload the content yesterday. Shit. Yes, Sanskriti. Nobody has got the project and all. To get the project first, they need to get the skill wallet credentials. So first thing is this is not shared with anyone. So please wait until the next week. You'll get everything. Session. Yes, guys. What are we having? So, what do we have to do on NASCOM Future Skills Prime? So, NASCOM Future Skills, everyone have registered, right? The reason for doing that is because that will be you will be having a direct connection with our Skill Wallet platform. So, make sure what are the email address that you have considered for the NASCOM Future Skills Prime in 7+ we have, right? So, you're going to get the same uh, the credentials for skill wallet will be sent to the same email address which you have used for future skills prime. Okay. So in that we do that regarding to the project email. WhatsApp. Don't worry about the project now. If you're not able to find the skill wallet credentials, you can do mention it in the we have a Telegram group, right? You can mention that after. Yes, guys, don't worry about this logging and all credentials, be it in what is that, NASCOM, Future Skills Prime, or be it in anywhere. Don't worry about it now. Okay, you will get all your solutions by this week, by Saturday, or by next week, Monday. Everybody will get your credentials. Don't worry. Okay, even if you have made any kind of mistakes, you can just mention the same in our Telegram group. So operations team will come up with a solution. Okay. I hope this is clear, right? Yeah, it is. Yeah, digital application fundamentals. You can do it. Okay, if anyone is having any kind of trouble with the login credentials or with the email address that you have used for both, like in Future Skills Prime, you can mention it in the later. Yes, guys, please understand that you will get to know about each detail, okay, every minor details about the project, everything in the next in the coming week. Don't worry. Now let's focus only on the content for this week. By if we end this, then you'll be backed up with all your projects. Then you'll go ahead with your okay. Yes. Okay, don't worry, guys. You will get all your credentials. So, did you guys go home and then spend your 10 minutes of your 24 hours? What link do you need, Ayush? Okay, just everybody, please listen to me. I'll make it clear last time. So if you're having any kind of issues with your email address, like if you have mentioned one email, like your personal email address in NASCOM registration, and but you're getting your email address, but you're getting the meeting link in your like in your college email address, don't worry. If you have any kind of issues with your email address or be it in your skill wallet credentials and all, you will get to know the solution in the Telegram group itself. So I request everyone to be, what is that, stay calm. Okay, you just have to put your queries. The operations team will come up with the solution. Okay, you will get your certificates. Okay, don't worry. Yeah, you have to I hope it's clear now, guys. So, yes, guys, what did we study yesterday? Can anyone please summarize it? Okay, don't worry once. Will be added later. Yes, guys, tell me. What did we learn in the previous class? Only CNN? Diagram of large language model. Did we study? We learned about feed forward, correct? Then what did we study after that? Single layer perceptron, right? So first, what is the CNN? Where do we use the CNN? Now tell me, like, what do you understand by this term CNN, convolutional neural network? Yes, guys. Yes, facial recognition, convolutional neural network to minimize the parameters of pictures, okay, or recognizing the edges in images. And yes, so there were like, what do you say? There were like process, right? Yes or no? So first, initially, we're going to get into the CNN because in case of ANN, that is artificial neural network, we are not able to find the patterns like if the given data is very complex. Okay. Now, Given the data is complex means if the data is in terms of images, which is like grid-like structure, it was very difficult for the artificial neural network to process the data, isn't it? Now, when coming to the convolutional network, we have this solution given, isn't it? Now, there are like five process, right? Like to consider the input image that we're going to give, that will be in terms of pixels, which will be converted into what we can say, array, isn't it? The numbers. Next, we are going to use this kernels or filters. Okay, why do we have to use this kernels or filters? These are used to find the edges or like text or what is it, shades or any kind of features that is available in our image data, right? So once you have these next, we have this pooling layers. So in each of our convolution layers, so the output from our input text sliding over our filters, the output is nothing but a feature map, right? So these feature map will also be having this pooling layers. Here we have max pooling and then average pooling. So we're going to consider multiple hidden layers. Then finally, you will have this fully connected layers where you're going to have the where you're going to have before that you're going to have a flattening layer where you're going to convert all your two-dimensional data, whatever you're having, that will be converted into one-dimensional, right? And this will be sent to your fully connected layers where here you will be able to see all the neurons getting connected to the previous neuron, that is the previous inputs. Okay. Next, at the final, depending on the type of data, depending on the type of output that you're like predicting, if it is a two class, you can consider a sigmoid, and if it is a multi-class, you can consider the softmax activation function, right? So that is what we have learned, right? So any doubts about this? Yes. No. Okay. So now what we will do is we'll directly dig into CNN. So we'll take up a sample from everybody has heard of this word MNIST dataset. It's like an handwritten digits, ranges from 0 to 9, 0 like 1 to 10. Handwritten digits, has everyone seen? So we will not be going on with the handwritten digits because it can be done with our machine learning itself. Sorry, what like normally everybody goes with MNIST handwritten digits itself, but now for our class, what we will do is we will go with fashion.mnist. So in this, what we will do is similarly, just like we had digits, handwritten digits in case of MNIST dataset. Now we are going to replace that with a fashion network, meaning we are going to have for the label one, we might have shoes, we might have sandals, we might have pants, shirts, like skirts. So these are the things that we're going to have the images, okay? And moreover, we're going to have these images in terms of a grayscale. So what is this grayscale you're going to have in income in terms of like gray images, okay? Not a colored image, okay? So let me show you. Everybody would have seen this. So I think I have opened it. Yeah. Yes. Hope everybody are able to see the screen, right? Yes or no? So here you have this MNIST fashion data set where you will be having for in terms of here, what did we have in terms of MNIST handwritten digits is in case of this zero throw, that is in place of t-shirt or laptop, you had zero number. Okay, that is handwritten. In the similar way, you have it for till 9. Okay, but in case of here, what we're considering is we're considering this fashion image data set. Okay, so if you see, we have this label as 1. So if you see here, these are the images that we have, right? So these are the input images that we have, and these are the output, which are nothing but labels. Okay, labels are nothing but the target or the output that we can consider. Okay, so now what we're going to do is we're going to train our CNN model to what is that, to get you the classification. Okay, how many classes do we have here? We have around 10 classes, right? Doesn't it? So given an image, what it will do, we will let the machine understand, okay, find the patterns in our image through our convolutional neural network. Okay, so this convolutional neural network will have, they have so many things to consider, right? Starting from how many convolutional layers you're going to consider, what is the pooling layers, and then where is the fully connected layers, and what are the optimizers that you're going to consider, and yeah, depending on the output, what is the activation function that you're going to consider? Is it active? Is it a sigmoid function or softmax activation function? And between each of these convolution layers in the hidden layers, you will be having this convolution layers followed by pooling layers, and this, whatever the output that you're going to get, this has to be activated for the activation function, right? Now, like mostly we will be using this ReLU activation function as if you're getting any kind of negative values. Okay, so that will be ruled out, meaning it will be given the value of 0, and meaning it will only consider the heavy, like much effective one neurons. Okay, so now what we can do is, now please open your Google Colab notebook. Now we'll start doing the coding part. So let me share my screen. Is it clear about the data set? So we're going to classify this. Okay, so initially we were having the all kind of data, right? Like textual data, numbers data, but here we are going to deal with the images data. Okay, so let me open my Google Colab. Yes, guys. So let me share my screen. I hope it's visible now, right? Now let me open my new Colab notebook. So in case of machine learning and all, since we have the data set, right, it was having the numbers and the characters in text. So it was very easy for us to, we didn't need much of the computation part, right? But since we're going to deal with image data, okay, you definitely need GPUs, that is graphics computational power. Okay, the computational unit. That is, we're going to use GPU instead of CPU. Okay, so let me start by giving my file name CNN underscore fashion MNIST. Okay, so I've named it. Now I've told you, right, you have to have your you have to connect your notebook not to your CPE but to your GPE, as we're going to do with lot of images, right? So it does need a lot of computation power. Okay, so for that, what you have to do is you have to go to this thing called as connect button you have, right? So go to here and then click on this connect to a, sorry, change the runtime type we have, right? So you can click on this, change this runtime. Okay, and then you can select this T4 GPU. Okay, is it clear? By default it might take a CPU, but since we're dealing with images, I request everyone to connect to this T4 GPU. Okay, I hope it's clear, right? So connect this, then click on save. Then you can click on this connect button. Okay, so now this is connected. Now we just scroll over, you will be able to see now our Google Colab is connected to our GPU itself. Now here we can go and then start doing our code. So please first mention your Google Colab notebook name, then followed by that. Now, what is the first thing? Now you have to understand two things. Okay, one is sorry. First thing is you have to understand this TensorFlow. Okay, so what is this TensorFlow? It is like a free open source machine learning, a framework you can consider. Okay, so what is this? Free, you can consider open source. It's the same thing. Open source machine learning framework. Okay, so what does it do? It actually that mostly depends on, that mostly works on our deep learning models. Okay, deep learning projects. Is it clear? So what is this TensorFlow? TensorFlow, it's a framework where we're going to use for our machine learning projects, and most importantly what we're going to do is we're going to use it for our deep learning projects. Okay, and there is also another thing called as Keras. Okay, so what is this Keras? Keras is also a library you can consider. So since we are going to deal with so many convolution layers, okay, pooling layers, fully connected layers, all these things are there, right? So to provide this, there has to be some kind of library which is like a which hangs on top of this TensorFlow. Okay, this Keras. So what it does, it is going to have all the requirements that you like. It is like not having the you don't have to start it from scratch. Okay, there is already like features available. Okay, there are already some libraries available where you can use it for your deep learning projects. Okay, and one does that produces is this Keras. Okay, it's like an API from where it's going to which is going to get all the libraries for this TensorFlow from this TensorFlow. Okay, so which is this? It's an API for our building. We have to build our own convolution layers and all, right? So everything will be built by using this Keras. Okay. So these are the two libraries that we're going to use. Okay. Okay. Now let's get into our thing. I hope you're done with this, known with this image data set, right? So this is our data set. So this is our MNIST fashion MNIST data set. So here we have our input images. Okay, for each of these we have the output, that is the label. Okay, so shirts we have the label as 0, Trousers, we have the label as 1. Pullovers, we have the label as 2. And goes on until ankle boots. Okay, then it has a label of 9. Is it clear? Now, what is the first thing? First thing is what? We have to import all our necessary libraries, right? So, for that, let's go to our Google Colab, and then we have to import first TensorFlow, because it is the framework that we're going to use for our deep learning model, right? So for that, we are going to use this. So what you have to do, you're going to first import the TensorFlow and and you'll be renaming this, or you'll be giving an alias name as TF. Okay, the reason for having this as is aliases is you don't have to repeat the same name again and again. Like rather than having the big name every time mentioned in your code, you can make it short. Okay. So next, let's since we are going to use this Keras. Okay. So for that as well, we have to import that. So what you have to do from Tensor, right? So not import from TensorFlow. You're going to import your Keras. Since since we're going to have this pixel values, right? Images will have pixels, right? And these pixels are nothing but the arrays. Okay, and we're going to use this NumPy to do some calculations. Okay, so hence we're going to import this NumPy as NP as well. Import. So once these are enough. So now let's execute this. Hope it's clear, right? So TensorFlow, it's a framework where you're going to do machine learning projects. Okay, and most importantly, you're going to work on your deep learning projects. Next, from deep learning projects, since you will be working on what is it, so creating so many layers, right? Convolution layers, polling layers, and all. For that specifically, there is a specific library called as Keras where it is going to provide. Okay. Next, we have NumPy to do some numerical calculations. So once this is done, so what is the next thing? We have to load our data, right? So for loading our data, let's name it as data loading. Next. So by default, I've told you, right? We have this Keras. So if you want to get to know about the what do you say? All the available data sets that we have two options. Okay. From that, what we can do is first, let's get to know about create here. I can see what are all the data sets available from the Keras. Okay. Is this done? Now, for that code, so what I'm going to do is I'm going to go for my TensorFlow. Okay. And I can directly go and then click on this keras.datasets.import mnest. But I don't want that. So what I need is I need to see all my data set, right, in the Keras folder, just like we had iris data set, right? Similarly, we're going to have this iris dataset from our own datasets in the machine learning model, like from scikit-learn, isn't it? The same way, you're going to have so many datasets from Keras. Okay, to find out that, first we have imported. So we have imported. This is done. Now let's list our all data sets. So we'll create a variable called as datasets, and in this I am going to create a directory. So where am I going to get all the data sets? From the directory called as this Keras, and I'm going to use this dot operator to get all my data sets from the Keras library. And then what I'm going to do, I have to print all those things, right? For that, what I'm going to do, let me create a comment that listing the data sets, listing all the data sets. So how are you going to do it? You're going to use this for, okay, for loop. So what are you going to do? You can consider I, okay, or you can consider data set itself. You can consider data set. Since we're going to know about the data set name, we're going to consider data set name. Next, from where are you going to get your data sets? From your this variable, right? From this directory. So now, if I'm going to just print out this dataset underscore my name, what this will do is this will include all your files from each of your data sets. So let me run it and then show it to you. Are you guys able to see that? So these are all the data sets that you have, okay? But these are all the other things that you don't need, since you're only going to list the data sets, right? So for that, in that case, what you have to do is you have to have this another loop if statement that you can consider. So from this, what are the things that you don't want to consider? You don't want to consider these things, right? So for that, what you can do is you can have this if not in a data set, okay? That is our okay I then. So what are, if you can observe, we have this starting button with this underscore, right? So if you're going to exclude this, we're going to have all the remaining data sets, right? So to have that, what I'm going to do is I'm going to have this start with. So what does this start with? Yeah. Starts with, it starts with what? It starts with this one, right? This underscore. So that I have to mention within the quotes. Okay, I've mentioned that, right? Now I can go here and then click this. Now what I can do, I have to go here and then not here, as you have this conditional statement, this has to come under below this. Okay, so first what it will do, you're going to have this for loop. Okay, this is an initialize, this is a what is not a random thing. You can consider anything, you can consider your name or anything I. So what this will do, this will go to each of these range data sets value and then do what? If you find this, okay, if not in this one data set, okay, you're going to print this, meaning what? If you're going to find this one, okay, this ashes, don't find, if you have only if data set underscore that starts with this one, you'll only be printing this first until from built-ins with spec. Okay, since you don't want these, you can have this if not. Okay, remaining these you will have to print out the other things, right? So for that I may use this if not. Then if I'm going to run it, I'm going to have all your data sets. Okay, so from this, what we are going to do is we are going to consider this fashion underscore mnest. Okay, is it clear? Now from Keras, you are able to see around 10 data sets. Sorry, 9, right? Yeah, 9 data sets. So out of these, let's go on with our first, for this class, we're going to, let's go on with the fashion underscore mnest, then we can go on with the CIFAR. Okay, so now what do we have to do? We have to have our data, right? So let's load our data. So for loading our data, I'm going to split that into train images and then test training images and then training labels. Meaning what? We had this what is that? X test, sorry, X train, Y train, X test, and then Y test, right? In a similar way, we're going to have this X train in terms of X train, sorry, train images and train test images, and for outputs that we had a Y test and then X test, right? Here we're going to have train labels and then test labels. Okay, so let me type this. So train underscore images. Yeah. If you see, so what have I done? I have so this is my, in case of machine learning, we had X test, right? Sorry, X train, right? And then we had X test. Similarly, Y train and then Y test, isn't it? So in case of images, we have these inputs, right? that is extrain, and labels are nothing but the output that we have. That is the testing thing. Okay, so how are we doing this? We are having this Keras. So we are going to our Keras library and then getting to our submodule called as datasets. So from this, what are we doing? So we are literally getting the fashion MNIST dataset, and then we are loading this into our variable, these variables. Okay. So literally what we are doing is, so whatever the dataset that we have from this Keras, that is fashion MNIST or this fashion MNIST, that we are loading and then storing into our these things. Okay. So what are these things? These things are nothing but our X-train and then Y-train. Similarly, what we had in our machine learning. Okay, we are literally, what we can say is we are literally unpacking. We have this unpacking, right? Like 80 to 20% of train test split. The similar way we are doing this here as well. Okay. Now this is your data loading is done. Okay, let's run this. No, this is taking a bit time. So once this is done, you will be able to see this. Okay, three tick mark with a green tick mark. Next. So what are the next thing that we can do is we have to pre-process. Similarly, in case of machine learning, we had a standard scalar, right? So if you had a range of values ranging from 1 to 1000, now to get it to a normal one good range, one good scaling, you would consider the standard dot scalar, right? In the similar way, what we are going to have is we're going to have this normalization. So what is this normalization is? So normalization is nothing but to have since we are going to have this pixel values. Okay, meaning we're going to have the image, right? And these images will have pixels, and these pixels are nothing but the inputs, which is nothing but our arrays value. Okay, so to make it into and I forgot to mention, so we have this one images. So 0 for the black color and 255 for the white color. Okay, this is our color code. Okay, so if you see any kind of black, okay, dark color, that means that it has a value of array value of 0. Okay, and if you see 255 value for your image, that shows that it is of white color. Okay, I hope it's clear, right? So this is very, very important. Okay, let's leave about this. Now let's do our pre-processing technique. So let's name it as pre-processing. Okay. Now for the pre-processing, so how do you have to do pre-processing? First thing is we have to, what are all input, what are our what is the training data? We have this, we have our training data as train images and then test images, right? Isn't it? So these images are nothing but our training data. These labels are nothing but our outputs. Okay. So this comes under what? This comes under supervised learning, and that is classification, isn't it? Now let's get what is it? The reason for doing this pre-processing is we are going to do some normalization. Let me mention it here itself. Normalize. We are going to normalize our pixel values in our image. Okay. because since, let's consider, you might have different values, okay, but if you want a constant, what is it, if you want a range of values, okay, you have to normalize it, okay. It's similar to we having our good scaling, okay. So we have to make sure we're going to have this normalization considered. So what this will do is, instead of having values ranging from what do you say, 0 to 255, you will have a range of values only between 0 and then 1. Okay, all the image value, all the pixel value that you have in each image, right? So that will be scaled down to 0 to 1 range. Okay, so let's do that. So it will be between 0 to 1. Now let's get on with our code. So how we are going to do it? So let's get our training data images. Let's scale this first. So how are you going to scale it? You're going to scale using our this one. What is it? 255. Why 255? Because what do you say? The reason for having this one is, by dividing it, you will definitely go, because the maximum range is 255, right? So we're going to divide that by 255. You're going to get a maximum value, that is, yeah. If you're going to you're going to get a value, only the maximum value that you're going to get is 1 itself. Okay, and images, divide that by 255, because all the images will be ranging from 0 to 255 itself, and we're going to do the same thing for our images as well for the testing data. Okay, so this is done, our pre-processing is done. Now let's do one thing. So sorry, I forgot to mention, let's get to know about our how many data we have. Okay, we can go train shape. Sorry, you can have this. Okay, so what is your, how many data samples do you have for training images? You have around 6,000 images, okay, input values, and out of these, how many pixel values do you have? It is, each image will have, it is of 28 cross 28. Okay, next, similarly, let's do it for our training data as well. Let's go on to that labels. You will get to see. So how many labels do you have? Do we have? Should have around. It ranges between 0 to 9, isn't it? Meaning you're able to see these dot dots, right? So these dot dots are nothing but these are all the values that you have. Next, if you want to go and then get to know about your testing images as well, test labels as well, test images. Yeah, here you will be able to see. Okay, should have not get into this because you will be getting this a lot. Let's not have this. Okay, I wanted to show you this. Let's not this. So what is your data set? It is about like 6,000, your training data, and coming to your testing images as well, you will be having the remaining 10,000. Okay, let's print this. Yeah. And now see the difference. For training, you're having around 6,000, 60,000, and for testing, you have around 10,000. Okay. Now, what we will do is, I've told you, right, since this is a grayscale image, so here we have another concept called as RGB. Okay. We have this RGB. Okay. So with this RGB, so red, this is nothing but red. Okay, so with these three combination, you can with these three combination itself, you are getting all the colored images. Okay, so if you don't want any of these colors, if you mention only one value, that means that it belongs to a it meaning these belongs to a channel itself. Okay, so if you're going to consider one, that means it is a grayscale image. But if you're going to consider the channel value as 3, it is of colored images. Okay, now let's go and then reshape our data. So this is our image, right? Now let's reshape our data so that we can give this for as the input for our CNN. So how are we going to do it is, so first thing is what we had this what is that values, right, for our images. Now we're going to convert that into our grayscale image. So how are you going to convert that? Going to use this train image is equals to, next you have to have this mentioned. So here you will be mentioning, okay, so here you will be mentioning what are you initially you had this one itself, but now what are you trying to do? You're trying to convert them to a grayscale image. Okay, by having this, so 60,000 represents all the data example that you have. Next 28 represents the pixel values, 28 in height, 28 in length and breadth. Next you have this one as the channel. So what does this one represent? It represents a, what does it represent? So it represents nothing but our grayscale image. Okay, now that is done. Now we also have this concept called as one hot encoding, right? Is any idea, guys, what is this one hot encoding? Yes, guys, what do you understand by this term one hot encoding? Let me show you. So we had this encoding, right? Where we had converted our categorical data into numerical values, right? So that is a kind of feature engineering that we are doing, right? So the similar way, what we're going to do is we're going to do the same thing, but wherever we're going to find this a particular label, everyone will have it will be between 0 and then 1. Okay, let me show you with an example. Yeah, let me open a new tab and then show. So here you can see that first moment is to go to expand I hope everyone are able to see, right? So in one hot encoding, what we're trying to do is, so here, how many classes do we have? Here we have only red, blue, and then green, right? So in the first row, you have this one red color, right? So wherever you're going to find the red, okay, you're going to mark 1. And the remaining other 2 columns, you're going to represent 0 itself. So similarly, in case of blue, wherever you're going to find this blue column, there you'll be mentioning 1. Okay, and the remaining 2 columns will be the 0. So similarly, what we're going to do is, in our fashion MNEST dataset as well, what we're going to do is we're going to consider this one hot encoding. So whenever if you're going to find the label as 1, so that has to be shirt itself. Okay, what if it is 2, that has to be labeled as pants itself, or trousers, or anything. Is it clear? So what are we trying to do? We are trying to convert this in terms of 0 and then 1. Okay, so to do that, let's first, how many classes do we have? We have around 10 classes, right? So let's give a list name as 10, and inside this we're going to use this utils. So we're going to have a new variable called as train labels. So in this, what are we going to do is we're going to convert all our categorical data, okay, to in our whatever we have it in our categorical data, that will be converted to our this one hot encoding. So it will be includes, it will be combination of 0 and 1. So whenever it finds in first row, okay, or the first neuron, if it finds the trousers, it will be assigned with 1 value and the remaining will be assigned with a 0 value. So it does the same thing for all your 60 to 70, like 70,000 of your data. Okay. Next, when this is done, let's run this. Sorry. That is done. Now let's again print our training data images, training images shape. So yeah, training labels followed by our images as well. We have to use our print. Screen. Okay, okay. Okay. I'm sorry, guys. Think I was not sharing my screen. Now it's visible, right? Yes. Okay. So what I did was to have this one node encoding, first I had to consider the how many classes that I have, right? So I have around 10 classes. So in that, I'm going to convert each of the data point that I have between the 0 and then 1. So if I find the first input, that first neuron value, first input value, the pixel value, if it has trousers array, so that has to be having 1. The remaining has to be 0. Okay. It does the same thing given the classes. Okay. Next, what have I done? I have used this code. Next, I'm going to also get to know about my shapes, okay, of both my training and then testing data. Okay. So this is both the labels. Yeah, no problem. Next. Now, what are the next thing is we have done all our pre-processing. The next thing is we will be going on with our CNN. So now let's have this as CNN. Okay. CNN layers. So how are we going to do it is first thing. So what are the things we are going to have? We will have our let's mention it here. We're going to have our convolutional layers. Next, right. Next, we're going to have our filters as well. Yeah. Next, we're going to have what are the next thing? We're going to have our pooling layers. Next, fourth one, we're going to have our fully connected layers. Right before that, we have to have our flattening layer, right? Next, we're going to have our fully connected layer. And finally, we're going to have our output, isn't it? So depending on the class, so as we're dealing with our fashion, this one, we're going to consider softmax. Softmax function utility. Dimension function. Okay, so these are all the steps that we're going to have. Hope it's clear, right? So these are all the steps that we're going to consider. So for that, first we have to have our what? First thing is we have collected, we have gotten our data, we have did some pre-processing by normalizing. Then we also have this one hot encoding as well, where now we have our input as the in terms of numbers itself, right? Now we have to build our model, right? That to a CN or the convolutional neural network. For that, let's create a variable name called as model. So in this, let's import our keras. Okay, then we're going to have the sequential. So why sequential is because we will be going from one layer to another layer, right? We will not be directly going from input layer and output layer, because you want to have the first thing is input layer, next is the hidden layer, then followed by another hidden layer, then finally you'll be getting into the output layer, isn't it? So since it is in sequence form, you have to have the sequential. Okay, it's clear. Now let's open a bracket, and inside these we have to give our input. Okay, that is our size of our image. Okay, that is our, we have to give the input image, like the size of our input images. What is its size? Okay, for that we have to have this keras itself. Let's consider our keras. Okay, and this, what I'm going to do, I'm going to input my images. Okay, so what is it of? I will be giving the shape as well. So initially I've considered, right, it is, so it will be of 25 28 cross 28. So initially here also I'm going to consider the same thing. So shape, now I'll be mentioning the shape as 28 cross 28, and it will be of, let me consider the space as well between these. Okay, now why one? Because I'm going to consider only the grayscale images. Okay, now it is better to have it in down. Yeah, it's better we have it down because we have so many other factors, right? Convolution layers, pooling layers, and all. Clear. So we have done setting up our, let me give you this as well. So what are these? We are trying to give the what is it? Define our input image size. Okay, so it will be of 28 cross 28 of grayscale images. To have this, we are going to consider this code. Now, once this is done, now let's get into our, okay. Now let's bring our first convolution layer. Okay, let it be one. Now inside these, so how do you going to create your convolution layers? So there is a code. So where you can get that, we're going to get it from keras, and you're going to have this layers is another submodule. From this you're going to consider this con 2d, that represent, you're going to consider convolutional layer. Okay, sorry, con 2d. Okay, so here what do you have to do? You have to mention your size, isn't it? What is your size of your convolution layer? So in this case, I'm going to consider, let's consider 32. Okay, so what are these 32? 32s are nothing but what? These are 32 are nothing but filters that we can consider. Okay, I'm going to consider 32 filters for my first input image. Okay, so whatever the image that I'm going to have is, so I'm going to have a image, right? So that image will be sliding over these 32 filters. Okay, for that I have to mention that this one, like I'm going to consider as 32. Okay, now I have to mention the size as well of how much is my what is the filter size. So it will be of 3 cross 3. And what is the activation function that I'm going to consider? That also we have to mention, that is by activation. So here I'm going to consider ReLU. So why ReLU? If I'm going to get any kind of negative values, so that will be what is that, rounded off to 0 itself, negative values. Okay, and I'm going to consider this padding as well. Okay, so padding as well, meaning if you want to add any kind of adding new pixel values to your image, you can add that. Okay, by having this padding as same. Yeah, yeah, that is done. Now let's also have our max pooling layer. We can have average pooling and then max pooling, but here I'm going to consider this max pooling. So from keras.layer, I'm going to consider max pooling. So what this will do, so whatever it has the feature maps, that is the output from our convolution layers followed by our sliding over our filters, right? So this will be, we will be having this max pooling layer. So what this will do, out of the feature map that it has, it is going to consider the maximum value from each matrix, that is from each um, feature map. Okay, so for max pooling, what I'm going to consider is, I'm going to consider like a matrix of 2 cross 2. Okay, I'm going to consider 2 cross 2 means what? You're going to consider 2 columns and 2 rows in each of your feature maps. Okay, so this is done. Now let me go to the next convolution layer, that is the next hidden layer you can consider. You consider 2. Okay, so let me do the same thing. Yeah, it is coming. So similarly, what I will doing is, here I'm going to consider 64. So initially I might have considered 32 filters. Now in the second convolution layer, I'm going to consider 64. Okay, and activation being, and the size of my filter is 3 cross 3, and the activation function is ReLU, padding is same, and here also I'm going to consider the, what is that, max pooling as well. Now these are all the hidden layers that we can consider. Next, if you, what are the thing, we have this feature maps, everything learned, right? Now we have to convert this two-dimensional space into one-dimensional space, right? So for doing this, what we're going to do, we're going to use this concept called as flattening, right? Isn't it? So let's get into this on this one. So if you see here, we have done our convolution layers, we have specified filters as well, pooling layers, max pooling is done, and last thing is what, we have to go for this flattening layer. Okay, so that is what we're doing. So for flattening layer, next I have to consider this keras dot. The keyword for flattening layer is flatten. Okay, so but before that I have to consider this layers. From these layers I'm going to consider this flatten. Okay, is it clear? Now what are the next thing you have done with your flattening layer? What are the last thing? You have this fully connected layers, right? So to have this fully connected layers, just like we had flattening layer, we had flatten, right? In case of fully connected layers, we're going to have this dense. Okay, keyword. So let's have this dense. Okay, so the code is keras dot. So here as well, we have to mention this is the last um, layer. So here we have to mention how many classes you're going to have. You're going to consider. Okay, so how many classes we are going to have? Sorry. In dense layers, or in flattening fully connected layers, what we're going to do? We're going to have all the first thing is you're going to flatten all your two-dimensional space feature maps that you're having into one-dimensional space, into one-dimensional vectors, right? So this vectors, each vector will have a particular neuron. Okay, each value that you have, it will be assigned to all the neurons in the next layer, right? So here as well, we have to mention how many neurons that you will be considering for your dense layer. That is for fully connected layers. Okay, so here I'm going to consider randomly activation function as like at 128, and the activation function that I can consider is ReLU itself. Now here I have to have, did I mention our number classes here? Okay, so what we have to do is we are going to also consider another fully connected layers, where this is the 128 neuron that we're going to have for our last one-dimensional vector that we're going to have. And the last layer, we're going to have how many characters, how many classes do we have? We have 10 classes, right? So to mention that, we're going to consider keras dot layers dot dense. So here I'm going to consider, since we are going to have 10 classes, I'm going to have 10 as the number. And here I'm going to consider activation function as softmax. Okay, hope this is done right. Now, what we have to do, we have to close everything. Okay, I hope this is done right, clear, right? So for starting from first, so what did we do? We started off with our first, we did a sequential keyword. So since we're going to go from in a sequence from input to hidden layers to multiple hidden layers, and finally we're going to go for output layer, right? So for that, we're going to use the sequential. Next, we're going to give the input size as well. How much is the size that you want for each of your neuron, or for each of your input, that you're going to specify with the 28 cross 28. If it is a grayscale, you can consider 1, or if it is like a colored thing, you can consider RGB value, that is 3. Okay, so we have specified a convolution layer 1 with 32 filters and 3, which is of 3 cross 3 matrix. Next, we have got consider the activation function as ReLU, and padding as well, same. Okay, so similarly here, what we have considered? We have considered 2 convolution layers. Then we have this flattening layer. So what is the flattening layer going to do? It is going to convert all the output that is has from the feature map. It will be in terms of two-dimensional space. Now that will be converted into a one-dimensional space, that is in vectors. Okay, so that whatever the output that it has, it will be connected with the neurons in the next layer, right? So that is here I've considered that fully connected layers. I've considered 128, and finally, since I'm going to have the 10 classes, I'm going to consider this 10 itself. Okay, now I've done all these things, right? Now if I want to get to see about how many parameters that it has considered in each of these layers, then I'm going to consider this model dot summary. Okay, so what this will do, this is going to give you a complete history or summary of this whole thing. Okay, so let's run this. I forgot to mention this comma here. So you can run. Yeah, yes, are you guys able to see? Yes or no? So in case of here in the first layer, you had this 320 parameters, and in case of second convolution layers, you had 18,496, and in case of dense layers, you had around 1,290 parameters. Okay. Now our CNN is done. Now what do you have to do? We have to compile our there's not training is done. You have completely had some kind of mention how many layers that you want for your model. Okay, now what you have to do is you have to also consider the metrics. How are you going to train? Okay, so what are the things that you're going to consider? What is the optimizer that you're going to consider, and what is the evaluation metrics that you're going to consider? So that all depends on this compile. Okay, so we're going to use this compile method. So what is the code for doing this compile method is? So let's start doing that. Model for, we're going to compile. Okay, so what are we going to combine? We're going to compile our we're going to, in this compile itself, we're going to mention our what is our optimizer. We have so many optimizers, right? So here we're going to consider optimizers. As I can consider Adam, there are so many Adam, AdaBoost, and these things, and among them I'm going to consider this Adam, and to consider this loss. Okay, I'm going to consider this categorical cross entropy. Okay, to have this loss function as well. So we learned about optimizers, right? So gradient descent, stochastic gradient. So among, in the similar way, we have this Adam as well. Okay. So what it is going to do is it is going to go back. So since this is a convolution layers, we have this back propagation as well, right? So what this will do, this will go back and then change the weights. Okay. So change the weights for all our in each of our convolution layers. Okay. Next, in case of this is done. Now let me consider the loss as well. You consider in case of loss as well. So what this will do, you have to have the loss function, right? आपका loss function तो है ना रहना है ना. So इसलिए we are going to consider the categorical cross entropy. Why categorical loss entropy is, so it is where you're going to, if you're having any kind of multi-classification. Okay, in case of multi-classification, you can consider this categorical cross entropy. Yes, Pratik, you can use the third layer as well. Okay, it's not an issue. You can do, because you will have more, what do you say? You'll be analyzing, you'll be getting to know your data more clearly. Okay. Now, here I'm going to consider cat. Okay. So here I'm going to consider categorical entropy, isn't it? So this is to mention, if you're going to have, if you're going to do a model in deep learning, which is going to have multi-classification. Okay. But if you had any kind of two classes, okay, in that case, what you can consider is, you can consider, I think, yeah, you can consider binary cross entropy. Okay. The reason for having this categorical entropy is, since we have more than two categories, right? That is, we have 10 classes. So hence we're going to consider this categorical cross entropy. Okay. And we also have to have this metrics. So what are the metrics that you're going to consider? As this is a classification algorithm, we're going to consider the metrics as accuracy. Okay, that is important. accuracy. Okay, I hope this is clear. Right now, let me print this output of whatever I'm going to have. You can consider just my model is compiled. So here, what are you trying to do? You're trying to literally specify what are all the defining for a training for training your neural network model. You're training your optimizer. What are the optimization that what is the optimizer that you're going to consider? What is the loss function that you're going to consider depending on the classes? Okay, and also to monitor the evaluate the to evaluate the model, you're going to consider this metrics as well. So here I've considered accuracy. Okay, now let me run this. I think I've made a spelling mistake. Yeah, compile. Now it is compiled. Now, what we have to do is we have done everything, right? We have done our pre-processing, we have done our convolution. What are the how many convolution layers? How many pooling? What is it? How much is our pooling layers? Is it max pooling or like we have considered max pooling? And we have done our flattening layer. Finally, we have our dense layer as well. Like how many classes that we are going to consider, right? Now let's train our CNN model. So for that, let me going to consider history. Okay, this is a variable where I'm going to train my model. So to train my model, what I'm going to do, just like we had model.fit in our DM machine learning, right? The same way I'm going to use this model.fit. Okay, so what images I'm going to do? I'm going to have the train images. Okay, and I'm going to have my train labels. Okay, and I have to mention this epochs as well. So what is epochs? I've told, right? Epochs are nothing but one complete cycle, okay, of your convolution layer, starting from input layer to multiple layers and then going to output layer, okay, and then coming back again after seeing the error. What is that error? It comes back using the optimizer called as Adam. We have, okay, it is going to optimize by changing the values of your weights and then biases for each of your neuron for your input values. Okay, this is going to happen. Okay, so here I have considered epochs, meaning what? It is going to have 10 cycles. Okay, and I'm considering this validation split as 0.2. Okay, so why 0.2? So what is this 0.2 is nothing but you go to it's like how many are going to consider for your training or validation sets. Okay, here you will going to consider two things. Okay, one is training data, next is testing, and the other one is validation. Okay, so once you're training itself, if you want to validate how it is performing, you can mention that as well. Okay, here I've considered 0.2. Okay, the remaining can be left for your testing data. Okay, here I'm going to consider 0.2. Okay, and let me also consider the batch size as well. How many batches that I will be considering? Okay, meaning what? How many? What do you say? How many values that it is going to update the weights? Okay, it is not going to go for each neuron, on each individual. What is that? Each individual inputs. Okay, instead of having that, if you're going to do that, it is going to take a lot of them, right? So to not having that, what you're going to do, you're going to consider some batches. Okay, so for that, let me also consider batches. Batches also we can consider the batch size as normally we take batch size as 64. It depends on you. Okay, 64. Okay, now this is done. Sorry, because out of 80%, let's only consider 20. Let's consider only 10%. The other 10% or 20% can be for our testing data. So we have our epochs, we have what to predict with our training images and then training labels. So these are training data. So let's predict this. So this is going to take a lot of time. Let's run this. So this is one epoch. So it is going to take a lot of time. Okay, here they will be mentioning it. So it might take, you have around 844 steps to complete one epoch. And as you see here, you are able to see your accuracy as well, and your loss function and your validation accuracy as well. Okay. So if you're going to, everybody have heard this, right? Training and then testing. If you're going to give training for 80% of data and the other 20% it will be for testing, right? In case of here as well, we're going to consider validation. So what this will do, it is going to validate the training at the, what is it? It is going to validate the training data itself during the training of your, meaning you will be evaluating your training data, okay, by having this validation itself. Yeah, this is done. Now if you see, if you observe, initially you had the accuracy of around 77%, right? Now after having this 10 epochs, you are having around close to 96.71, isn't it? And if you see here, you're also able to see the loss also being reduced. It initially had 62% of loss, and finally it had only around 8% of loss. Is it clear? I hope it's clear, right? Now let's summarize, let's evaluate our model. Okay, let's evaluate. So how to evaluate our model? So we're going to evaluate our model. Okay, right. So let's evaluate our model. So this is what, how we're going to evaluate is, let's consider we are done with our training data. Let's evaluate with our testing data, how it is performing. Okay, so let's go. So we have this dot predict, right, to predict on our testing data. So here let's directly evaluate on our testing images. Okay, testing data. So how are we going to do it? Let's go to consider our testing. How many loss that we're going to have? We can consider that. Or we can consider this test accuracy. Let's consider test accuracy. Test accuracy you can consider. First thing, that is what we need from our data. So to have that, you have to go then evaluate. So model dot evaluate. Okay, so what are you going to evaluate? You're going to evaluate your testing images, right? Now this is done. Let's print our. Okay, let's consider this as well, loss as well. This is also very important. Okay, so let's print out this one. Testing accuracy followed by how much loss. Yes. So it's showing us around. Okay, I forgot to mention about this Verbose itself. You have your, sorry. Yeah, we have around 91% of your accuracy and then 10% of your 28% of your loss. Okay, I think these are all done, right? So if you see here, you can consider. So what did we consider here? Yeah, this is what I was about to mention. This softmax. Are you guys able to understand? So here we have considered this softmax. The only reason for having this softmax at the end is to consider the multi-classification. Okay. Oh, I hope this is clear, right? So I'll be sharing this slide at the end of the session. Yes, guys, any doubts until here? Yes, we can have a long break itself. Did you guys understand this CNN now? Sir, why all this using ML and DL? I didn't get you, Amit. As a humans, everybody are able to classify between the different classes, right? Given the shown the image, but how will the systems or the computers will get to know? They have to have some kind of what is it? Learning, right? They have to learn some other way. So how are they going to learn? Is they're going to learn through these deep learning techniques. Okay. Yes, Shreya, we did this. We had this trained train images divided by 255. It is like a normalization. Okay, as you will be having your pixel size ranging from 0 to 255. Okay, to have it a normal scaling value between one range, you will be normalizing it just like we had standard dot scalar, right? In case of machine learning, the similar way, to have normal value, standard value, we're going to normalize this pixel values with this 255. Okay. Yes, Shreya, you're going to use this 255. So that is the maximum value, right? If you divide by the maximum value, you'll definitely get that divide by, you're going to get the value as one itself, right? So here you're literally having the range between 0 to 1 value itself. Okay, not more than that. So what we will be doing is on the last code, we will be literally evaluating how our model is performing. Okay. Let's see this. So in this end of session, okay, just a moment. So let me come from the first. So what did we do is we imported all our necessary libraries, TensorFlow and Keras. Then we got to know about the different how many we were listing how many data sets that were available from Keras itself. So out of those, we considered fashion MNIST. Then we were making our we were loading our data. Okay, we were allocating our data into different training data and then the testing data. So here we have this training images, right? Testing and then training images. So these are all our images, that is our input, and for these input these are all the outputs. So in the similar key, this is what we're going to consider for our testing. Okay, these are all the testing images and these are all our labels. So here what we're going to do, we're going to training on our, we're going to predict or we're going to evaluate on our testing images, isn't it? Now here we did this, what is it, normalization. So it is a kind of pre-processing itself. The reason for having this 255 is because each pixel value will have a different values ranging from 0 to 1. Okay, but if you have this, it will be very difficult for the machine to understand, isn't it? And it might take a lot of time to not have that. So if you consider that between two values, between a range, okay, it will be very easy for the model to learn. Okay, as since why did they have to consider this 255 is by considering this 255, you will be having the value between 0 to 1 itself. Okay, the maximum value for the pixel is 255, isn't it? The 255 white color and 0 for black color. Okay, then we got to know about our images, shapes. Next, we have this one-hot encoding where we were converting all our labels into like mixture of 0 and then 1. Okay, next we had a CNN layers. What is the first thing? We had convolution layers, followed by filters, pooling layers, flattening layer, fully connected layers, and in the output layer, we were mentioning a activation function. So here we have considered sequential. Okay, that here we are going to mention how many filters that we're going to consider. Then, so first, we were going to first mention our input image pixel size of what is the length and breadth of your image. Next, if you're going to consider this one as well. Why one? Because the image that you're going to have is of grayscale image. If you're going to consider colored image, that will be of 3. Okay, by 3 it is the channel number. Okay, next for the convolutional layer 1, you're going to consider 32 filters of 3 cross 3, and the activation function is ReLU. And you're going to consider max pooling layer for every feature map that you have. You will have the first, like for 2 rows and then 2 columns of matrix. You're going to consider max pooling. Okay, here what are you trying to do? You're trying to do some dimensionality reduction. Okay, next similarly for second layer as well, and you're going to consider this flattening layer, converting all these feature maps into one-dimensional array. Again, one vectors. Next, you're going to have this one. So here, in case of fully connected layers, you're going to have the output of all in the flattening layer you will be having, right? So this will have a connection with all the neurons that are available at the closer to the output layer. Okay, and at the fully connected layers, in the dense fully connected layers are nothing but this dense layer that we can consider. And at the last, you're going to have only 10 neurons. Okay, so in this 10 neurons, you will be classifying based on this softmax. So this output will be in terms of probabilities, right? So depending on which highest probability, that will be given that particular class. Okay, then we are able to find this model summary as well. And we were compiling, given what is our optimizer, what is their and what is their loss function that we're going to consider here. They're considered categorical cross entropy. Since it is a multi-classification, if you had binary classes, that is two classes, then you can consider binary cross entropy. Okay, metrics is accuracy. Next, we are also, this is the model training that we are doing by using this model.fit. On what? We want to do it on training data, training images, and then training labels. Epoch system and validation split is also 0.1. Okay, so why this validation split? It is going to validate your training data itself, this training itself. जब ट्रेनिंग होता है ना वहाँ तभी हमको पता होता है कितना अच्छा परफॉर्म कर रहा है, हमें एवेल्युएट कर सकते हैं. Okay. Next, we're going to test it on our evaluate it on like test it, predict it on our testing images and testing labels. Then by imprinting those test values and then accuracy, we will be getting this. What is our accuracy and then loss for our testing data as well. Okay, so that's given around 91% of accuracy for your testing image for your testing data as well, and the loss is around also 28%. Okay. I hope this is clear, right? I'll share the notebook now itself. I'll not forget later. Yes, guys, I have uploaded the content. You can refer that. Okay. I have uploaded the content in our Google Drive. And here is the Drive link. Yes, guys, any doubts? I have uploaded the content. So in student readout section, we have uploaded the content. Yes, I have uploaded. Regarding the last class, I didn't, but I have uploaded the PPTs. You can refer that. Yes, guys, if you have no queries, you can leave the meet. Thank you so much. Please do practice at your home. Tomorrow, we'll learn about a bit of transfer learning. And then we'll try to do one more as well. Yes, yes. Today we don't have any quiz. We'll try to have it tomorrow. Okay. Yes, guys, if you have any queries, you can just let me know in the Q&A, or else you can leave the meet. Okay. Thank you, guys.